Now let us look at the construction of granular subbase and granular base layer, that is construction of wet mix macadam. So here we are discussing construction of this layer, the granular subbase layer, and this layer, construction of the base layer. We, as I said, we generally construct wet mix macadam as base layer in our country. So we discuss these two layers. So this picture shows the grading of the granular subbase layer using the motor grader. This is motor grader. Motor grader is used for spreading of the GSB mix. This is another view of a finished granular subbase layer. So what is this subbase layer or subbase course? This is an intermediate layer between the subgrade and the base layer. Essentially, it's a drainage layer. Of course, this distributes the stresses imposed by the traffic. What are the materials used for the subbase? It can be locally available materials like sand, gravel, muram, kankar, crushed stone, laterite, or even the materials from industry waste or byproducts like steel slag, pond ash, crushed concrete, or big beds. Any of these alternate materials, marginal materials also can be used, or these conventional materials like the gravel muram also can be used for subbase. In all, as seen in this picture, generally for GSB layer, you can see here, this GSB layer is mixture of graded crushed aggregates. You don't see any soil, any muram here. For all highway projects except for low volume roads like village roads, PMGSY roads, the subbase, we don't use the soil or the muram. We only use specified gradation of crushed aggregates to have the GSB mix. So, except for low volume roads, we don't use any muram or kankar or any plastic material in the GSB layer. So these are the gradations. There are 6 gradations that we can adopt for construction of granular subbase. This is the sieve size. This is the grade 1 gradation, grade 2 gradation, grade 3 gradation, and other 3 grades are like this: grade 4, grade 5, grade 6. So what you have to observe in the gradation is, you have to look at the gradation here. So there are some grades are missing here, some sizes are missing. So you know that GSB is essentially a drainage layer, so need to have more voids for better permeability. So we have open graded, coarse graded GSB and close graded GSB, dense graded GSB. So here you can see it is close graded. But irrespective of the coarse grade or the close grade, GSB layer serve the purpose of the drainage, the permeability of the infiltrated water. The other observation you have to make is passing 0.75 mm. See here, it is 0, maximum 8%. 8%. Even here also it is less than 5%. Less than 5%. That means fines need to be less in GSB so that the permeability of the water is not affected. So this is the material requirement as per the specification. Liquid limit maximum allowed is 25%. As I said, except for village roads, this liquid limit will not come into picture at all. This liquid limit comes only when we use any type of soil. Otherwise, this test do not arise at all. Similarly, the plasticity index maximum allowed is 6%. As I said, unless soil is used, these two do not come into picture. The CBR requirement is minimum of 30%. Of course, when you use crushed aggregates, even this also is not an issue at all. So all this comes into picture only when you use soil or muram in the GSP mix, which is done especially for low volume roads. So these are some of the quality control tests carried out for granular subbase. Gradation, one test for every 400 cubic meter. The Atterberg limits, one test for 400 cubic meter. Moisture content, again one test for 400 cubic meter. Density, one test for every 1000 square meters. So these are the construction steps for the construction of granular subbase. First one is the preparation of the receiving layer. We construct GSP over the subgrade. So we need to prepare the subgrade, ensure that there are no vegetation, and light sprinkling of water is required, and over which a static passes of the roller also need to be carried out on the existing subgrade before putting the GSB layer. So then spread the GSB mix mechanically by a suitable mixer with a provision to control the addition of water. Generally, motor grader is used for spreading the mix to the required slope and the grade. The mixing of the GSB material and the water should be done mechanically. Generally, grader is used for mixing. First, the dry aggregates are spread to the required loose thickness, and then water is sprinkled. How much? To get OMC. And then this water and the sprinkled water and these dry aggregates are mixed, generally using grader. And then again it is leveled using the grader to the required cross slope and the longitudinal grade. So once spreading is done, compaction is carried out using 8 to 10 ton vibratory roller for layer thickness up to 200 mm or 250 mm. For smaller layers, even static roller may be used. So this is next comes the construction of the base layer. What we discussed is construction of this layer. Practically, common man do not make out the difference between the base layer and the sub-base layer. Both are crushed aggregates. No soil is there here also. But if you look closely, this will have more voids to have better permeability, and this is a well graded dense mix. As I said, embankment is inferior to subgrade, subgrade is inferior to the subbase, subbase is inferior to the base layer, and so on. So this is a well graded dense mix, this is a open graded mix where you find more voids, but outwardly it looks both layers are similar and same. So we discuss the construction of the wet mix macadam or the granular base layer. So this is the gradation of the wet mix macadam. This is a sieve size and this is the gradation. So you can look here. This is a well graded mix. Well graded mix. Here also, if you go by the specification, any material used for the wet mix macadam should have Pi less than 6. But this question do not arise mostly because we don't use any soil in the wet mix macadam. So this is the permeable variation by the job mix formula. So gradation is very, very important, especially for the granular layers, of course, for bituminous layers also. And if you look here, this is the tolerance given. Tolerance given. That means if you check the gradation, then the deviation should not be more than plus or minus 8% for the aggregate size of 19 mm or larger when this aggregate is used in the binder or the base course. Of course, not to exceed 7% plus or minus 7% when this size of material used in the varying course. So depending upon the size of the material, the tolerance, the permissible variations are given for varying course, binder and base course. So this is a very important parameter. I was telling the density is most important quality parameter for soil layers. Here for granular layers, whether it is the granular subbase or the granular base, whether it is wet mix macadam, crusher and macadam, the gradation is very, very important. So that is the reason these tolerance limits are given. Lesser is the size of the material. Say for example 0.075 mm, the tolerance is plus or minus 2% for base and binder course, plus or minus 1.5% for varying course. So higher is the size, more is the tolerance. Lower is the size, lesser is the tolerance. So the permissible variation or the tolerance varies from 1.5 to 8%, plus or minus 8%. So this is the pug mill, also called the wet mix plant. This is here. This is the plant in which we produce the wet mix. So these are the hopper bins. The material are loaded into the hopper bins through loaders or through tippers, and then we have the holes here. So operate these holes so that the material, different size material, each bin will have different. Let's say this will have the dust, this will have 6 mm, this will have 10 mm, and this will have 20 mm. So based on the proportion decided already, so the openings are adjusted here and dry material falls on the conveyor belt below here, and this material is conveyed to this pug mill mixing unit, dry mix, and then water is pumped. How much required quantity to have the OMC? Both water and this graded aggregates are mixed here and unloaded onto the tipper, and the material is taken to the job site. So once the mix is prepared here, the wet mix is transported to the construction site, and the wet mix is to be paved at OMC using paver, and it is not to be dumped like this and then graded using a motor grader. It is not a good practice. So wet mix always to be paved at its OMC. See, same tipper, same paver, right? So wet mix is you can see the wet mix paving in progress. Same paver, same tipper, right? So this is another view, the construction, the paving of wet mix in progress. You can see the small video also, paving of wet mix macadam. the same paver, tipper, pencil. So that means this is mixture of the soil and the well-graded aggregates as per the gradation. See the profile. So to have a better profile, you can see this is a sensor paver. You can control the cross profile as well as longitudinal profile also. So this here in this video, you can see the compaction of the wet mix macadam. You can see the paved wet mix macadam layer is compacted using 8 to 10 ton class vibratory roller. This is single drum vibratory roller. Single drum vibratory roller. So the construction steps for wet mix macadam. First step is proportionate of the aggregates to be carried out to meet the required gradation, specified gradation as per MRTH specifications. The second step is preparation of the wet mix in the pug mill or in the wet mix plant, and then spreading of the mix using paver. Only exceptional cases, a motor grader can be used for spreading of the wet mix. So after spreading, paving, compaction is carried out using vibratory roller. Of course, traffic control during the construction is must for safety of the road user, safety of the crew. So these are the quality control tests need to be carried out during construction. One test for every 200 cubic meter, one gradation test for every 200 cubic meter, one aggregate impact value test for every 1000 cubic meter, one combined index test for every 500 cubic meter, and one density test for every 1000 cubic meters of aggregates used. So there are advantages of constructing wet mix macadam as the base layer, granular base layer. You know that there are other types of granular layers like water-bound macadam can also be constructed as a base layer. Crusher run macadam also can be used as a base layer, but there are some advantages of constructing wet mix macadam as a base layer. What are these advantages? So wet mix macadam is a homogeneous mix because it is prepared in a plant, in a controlled plant mechanically, and it is wet mix is laid using pavers so that we get better finish. You have seen the finish. Production is also quicker, and the mix can be mixed at suitable locations where water is available. You can install this wet mix plant wherever water is available and prepare the mix, bring it to the job site. Wherever means near the construction site, your project location. So because of premixing with the water, so because there is a moisture content, segregation reduces. Segregation reduces, and wet mix will give higher unit weight because it's a well-graded mix, and hence higher stability, higher strength. So less compactive effort is required to achieve maximum density because, as I said, it's a well-graded mix. If you even you check the wet mix gradation, it will have the quarried 2 mm, 6 mm, 10 mm, 20 mm, all kinds of aggregates. So you get higher density, and there will be uniform coating of moisture around all the aggregates because it is mixed in the pug mill in a controlled way. So that means less segregation, more density, more production can be done. Generally, the wet mix plant capacity varies from 50 to 100 cubic meter per hour, sorry, tons per hour. So more production, so more progress can be carried out. And gradation also can be controlled easily. you said controlling gradation is very, very difficult, and because it is wet mix macadam prepared mechanically in a controlled way, so controlling of gradation is relatively easier, better compared to other kind of granular layers. But again, there are some limitations for wet mix macadam. After the construction of the wet mix macadam, top layer is to be sealed immediately with a bituminous surface. This holds good for any of other layer also, like crusher and macadam also, because otherwise the gradation disturbs or raveling occurs. So stability becomes poor. So we should not we should restrict the traffic on the wet mix macadam layer till a bituminous layer is covered over the wet mix macadam layer. That is very important. And lateral confinement is another important factor. So neither side, because it is a granular layer, no binder, any type of binder in the mix. So confinement is required. Generally, this confinement is done one side, the one side is shoulder, the other side generally it will be the curb. So confinement is required for wet mix macadam layer. And if you look at the water consumption for wet mix macadam layers, it is high in the range of 3 to 3.5% or 3.75% or so. Where to bring so much quantity of water when there is no water for drinking in the scarcity areas is one question, one disadvantage people ask. So again, the construction steps as per the specifications, MRTS specification, preparation of the base layer, that is receiving layer. The second step is, as I said, confinement is important for wet mix macadam layer or any granular layer. So provision of lateral confinement, like the shoulders in advance, erection of curbs in advance is the requirement so that to have confinement. Then preparation of the mix. For small quantity of the mix, wet mix, a concrete mixer may also be used in exceptional cases. And uh, to check how much water to be used, as I was telling, it is OMC requirement. How do we check OMC for wet mix macadam gradation? So replace 22.4 mm material with 4.75 to 22.4 mm material. So any aggregate bigger than 22.4 mm need to be taken out while finding out OMC in the laboratory. So once mix is prepared, then comes spreading of the mix. Spreading, of course, spreading of the wet mix to be carried out uniformly, evenly. And as I said, the mix should not be dumped in heaps. Finishing or spreading is always done using paver. Exceptional cases, we can use grader. Care to be taken to avoid or to minimize the segregation during paving of the mix, transportation of the mix, or even preparation of the mix in the pug mill. So once the mix is spread, compaction is to be carried out using 8 to 10 ton static compactor for thickness up to 100 mm. For bigger lift thickness, vibratory roller of 8 to 10 ton capacity is to be used. During compaction, speed of the rolling not to exceed 5 km per hour. Any displacement occurring due to the rolling operations during rolling is to be rectified. So as said in other cases, here also we have to use small compactors in where bigger roller cannot be operated. And always rolling not to be done when the subgrade is in the soft condition or when you find subgrade is yielding or causing a wave-like motion. So we should always keep observing the roller wheel, and if you find any wavy like motion or any yielding on the surface, then we should stop the rolling and we should rectify, reconstruct that layer and then proceed further. So if irregularities during rolling is more than 12 mm, when checked with the straight edge, we have to loosen the surface and the required quantity of premix material to be added and rectified. So the irregularities not to exceed more than 12 mm when checked using straight edge. So any defections on the surface are to be rectified, and then the layer is to be allowed for setting and drying. So as I said, the layer should not be opened for the traffic. It should be opened for the traffic only after sealing with a covering with a bituminous layer. So then comes the other type of granular base layer, crusher and macadam. So what is this crusher and macadam? The crushed aggregates from the crushing plant is used as such. That means in the wet mix macadam, the preparation of wet mix macadam, what do we do? In the crusher, the sizes of different sizes of aggregates are stockpiled separately. Let's say 20 mm, 12 mm, 6 mm, quarried separately in the crushing plant, and then they are transported to the pug mill, and then they are loaded into different hopper bins, and they are mixed in the required proportion to have the required gradation of wet mix macadam. There what happens, we are separating, that is we are screening, and then we are remixing in the wet mix macadam the materials. Here for the in the crusher and macadam, that screening, separation of aggregate and then remixing is avoided. That is the biggest advantage. Comes to the requirements, physical requirements is same as to that of the other granular layers like wet mix macadam, WBM. Whatever the physical requirements specified for the wet mix macadam or waterbound macadam, the same holds good for crusher and macadam also. The construction procedure is also similar to wet mix macadam. So this is the gradation of the crusher and macadam. You can see here gradation of the crusher and macadam. So what are the advantages of the crusher and macadam? We are handling one material, hence the construction cost is cheap. But again, there are limitation is maintaining the gradation is very difficult, because we are transporting the dry mix directly to the job site, and then we are paving or spreading using the grader, and then we are sprinkling the water and then rolling. But when you transport the dry aggregates to the job site, segregation do occurs. Maintaining the gradation is relatively difficult compared to wet mix macadam. So while transporting the mix to the longer distance, aggregates may segregate. While spreading also, at some places we may find only fines, some places only coarse aggregates. So segregation is an issue. So during construction, the fine material tends to go down, resulting in loss of strength or stability, or even the compaction also becomes difficult. So these are the construction steps for the crusher and macadam. As usual, the first step is preparation of the base layer, receiving layer, that is the sub-base layer, or the bottom granular base layer. So we have to prepare the base. What do you mean by preparation of the base? We should check for the longitudinal grade or the cross profile, any distresses in that layer, all those to be rectified before constructing the new layer. That's the meaning of preparation of the base. So once that is done, then comes spreading of the material, mixing with water, and then rolling. So this can be done maybe with or without spreader. So for mixing, a blade is used for mixing, and before mixing and during mixing, water to be sprinkled, and we should ensure minimum segregation during mixing of this water and the aggregates. and then the mixed material is finished to the required grade using motor grader. So what is the first step? Bring the mix directly from the crusher to the job site, spread using grader to the required loose thickness, then sprinkle water over the spreaded layer, then mix using the blades, the generally the motor blades, grader blades, and then again level it using the grader to the required profile, then compact it using vibratory rollers or uh, the other appropriate rollers. So once rolling is done, check for the surface irregularities using straight edge, and then check for the surface finish also. So there are some salient aspects need to be duly considered during the construction of granular layers, whether it is GSB, whether it is crusher and macadam or wet mix macadam. We should know that the strength of these granular layers is achieved by interlocking of aggregates. So should ensure that that interlocking is proper. So this can be achieved by maintaining the gradation and also by compacting the layer properly. So another aspect is, as said, lateral confinement is must for granular layers, otherwise the layers in the edges loosens and stability goes down. So not to expose the aggregate layer with bituminous top for longer duration. So that means uh, the layers are to be not to be exposed without any bituminous layers, because traffic may move and gradation may disturb, the profile may get disturbed. So the aggregate layers, the wet mix macadam layers, with the crusher and macadam or wet mix macadam layers, not to be exposed without a bituminous top for longer duration. So restricting the traffic is very difficult. So at the earliest, these layers are to be covered with a bituminous top layer. And not to compact these layers, which is already compacted, when you go for the construction of new layer. Especially, you should not use vibratory passes. Static passes you can use by sprinkling water, but not to use the vibratory pass or already constructed, compacted wet mix macadam layer or crusher and macadam layer. As I said, the most important quality parameter for this granular layer is gradation. Gradation. Like I said, density for embankment and subgrade. Gradation is important for granular layers. So further, you can read in the MRTH book, 5th revision, also the IRC publication 109 on wet mix macadam. Thank you.